discuss how and why we need to develop the theory behind linguistic data sets for certain kinds of statistical phylogenetics. So like species, of course, or better yet, like isolated populations, languages have genealogies. Now, fundamental advances in biostatistics have enabled biologists to infer the evolution of related species and populations with increasing precision, and so it's entirely appropriate that linguists and others are now seeking to extend these techniques to language histories with the aim to develop new insights from linguistic data into social prehistory. Now, given that linguists have been assembling cross-linguistic data sets for over a century, one might assume, whether a linguist or someone else, you might assume that we have a storehouse of data at hand and that we're ready to proceed with these new statistical techniques. And my aim this afternoon is to persuade you that this is not the case, and to outline the foundational requirements of a theory of dataset design which addresses deficiencies in our current generation of datasets. So our discussion begins with the comparative method in linguistics, which was developed in the 19th century and has proven highly successful. This is why anthropologists, biologists use linguistic trees as reference trees in their work, for example. Now, it enabled linguists to work by hand with multifarious data to detect evidence of descent and interaction, so vertical and lateral, between societies in the past. Yet, the linguistic comparative method in its traditional form has its limitations. In principle, linguists work with roughly two kinds of evidence, either vocabulary items, that's what we're most familiar with, but also with structural features such as elements of word order, word composition, sound patterns, and so forth. There are very good reasons to believe that vocab-based signals become indistinguishable from random noise around 5,000 to 10,000 years' time. This may change with advances in understanding, but to my mind, we're not there yet. Structural features, on the other hand, for them, the phylogenetic signal that they convey is so weak and so ambiguous that it is justifiably discounted by most careful traditional research. And so, for 2 centuries, were the boundaries and the limits of linguistic prehistory as studied by language, but breakthroughs are starting to happen and many more may be imminent. And my focus today is on structural features, so I'm not talking about research dealing with vocab. So the question for this decade is, are these old limits surpassable? The comparative method in linguistics traditionally was a paper and pencil method, and thus it was limited not only by the nature of language change and the information destroying processes that go on, but by the low power of our inferencing techniques that were available. So with new developments in biostatistics, we now have the possibility of examining very large numbers of structural features to recover faint signals of the deep past. So what's the state of play right now? Well, the debate amongst linguists is over basic feasibility. Particularly, is rampant horizontal transmission an insurmountable problem to this kind of endeavour? Now, there's a lot of debate without much empirical examination. So fundamentally, I would say this question is an empirical one. We can go and look and get an answer. I've seen no convincing argument that success is impossible and therefore we shouldn't try. Once our early problems are identified and addressed, we ought to meet with success, however major or minor that turns out to be, which is another empirical question. However, there are substantial methodological problems to overcome. This is me speaking as a linguist to everyone, but also to linguists, of course. Not only with the statistical techniques which linguists seem to like to debate so hotly, but with the design of linguistic data sets, which so far, even for linguistics, has received comparatively little attention. So the problems I'll talk about arise when we wish to use linguistic data for new statistical purposes. So let me just review the uses to which the data is put. When languages have a historical relationship, whether vertical, horizontal, or both, their structural features will exhibit certain correlations which are due to that history. Statistical techniques follow assumptions dictated by the researcher and then objectively measure those correlations in order to infer phylogenetic relationships. Therefore, correlations are the empirical heart of the science, and the reliability of those correlations as a true reflection of history and not of something else is paramount. Now, history, of course, creates noise as well as signal, and that's fine. We have techniques for dealing with that. But if, in assembling our data sets, we created significant bias, then that would compromise the endeavour. And what I'll now argue is that currently, state-of-the-art data sets of structural features introduce exactly that kind of data, that kind of bias, quite pervasively. Now, to make the argument accessible and make sure you don't need a degree in linguistics, let me abstract away from the world of languages and sounds and attempt to convey the insight intuitively using a language whose words are made of coloured shapes. And here I'm showing you 6 words in that language. Now, we begin here with linguistics as a cognitive science. That's how linguistics views itself. Linguists are concerned with what speakers know, what they implicitly know in many cases, and we have extensive evidence that much of what speakers know about their language is couched in terms of abstract categories. For example, a human infant which was acquiring this shape language will learn that circles are special. Unlike squares and triangles, you can predict the colour of circles in this language. Circles are blue at the starts of words and green elsewhere. There is, we say, a single psychological category of circle in this language. Now, this is the kind of thing linguists do. On what basis do linguists conclude that? On the basis that speakers use these psychological categories. When speakers of this language coin new terms, circles will be blue at the start of words and green elsewhere. When a speaker of this language learns a foreign shape language, one of the first things they'll do is turn the circles blue at the start of the word and green elsewhere. That will be their foreign shape accent. So speakers do things with these psychological categories. They are real. So in this language, there's a demonstrable single psychological category of circle. If we're talking about sounds, we would call it a phoneme. Same kind of deal. And this is exactly the kind of fact, these psychological categories, that linguists are putting in their data sets. This language has one category circle. Another one might have 2. Here's another shape language. It also has a single category of circle. In this language, a circle is always the same colour as what comes to its right. And in a linguist data set, this language would be coded up just like the last one. This language has one category circle. If we're talking about sounds, it has a phoneme, just like the last one. Here's another language. It has a single category of circle once again. In this language, circles are always red. And so in the linguist data set, it'll get coded up just the same as well. It has one category of circle. Now, the problem here is that we are now building data sets that contain, again and again, what might be termed summary variables, such as, does a language have category X? The binary value of a summary variable, or the value of a summary variable like this, depends in some way on a host of other underlying microvariables, where the microvariables are concerned with small empirical observations that lead a speaker to posit an abstract category, like what happens at the start of the word. Now, the main problem with summary variables lies in the nature of this function standing in the middle. When you survey linguistic practice, what you find is that this function, which converts all the myriad of microvariables into a summary variable, is neither deterministic nor the same for all linguists. And that means summary variables, the one variable at the end, is assigned values inconsistently across languages, inconsistently across linguists. And linguists are aware of this fact, embarrassing as it is to us. Just to point this out with a concrete example, here are 10 Australian languages and a summary variable which has been used in a series of studies that I'll talk about shortly, whether or not a language has pre-nasalized stops. I won't go into what they are, but they're a thing that we like to talk about. And here are 6 microvariables that underlie that summary variable, and they're actual binary variables that are coded up for those languages. One if it's green if it's one, grey otherwise. And so for those of you who like to gamble, now is the time to place your bets. Which of these 10 languages will have been coded up with a 1 or with a 0 based on the underlying microvariables? Place your bets, and the winners are those. Not a good picture. This is not a useful comparative data set. This is the kind of data sets that linguists are using at the moment. These are the ones that we've mostly got across linguistics. So the problem with summary variables concerns how a single variable in and of itself is ascertained. Another problematic case is what we might call linked variables, where the problem is the existence of logical dependencies between variables. Another problem, another type, linked variables can, of course, undermine assumptions of independence, which are vital to many statistical phylogenetic techniques. They don't link together in a way that resembles linkage disequilibrium, so even if you've got a statistical technique that takes into account that, this is not the same kind of thing. Now, what we need to know with all of what I've said is this actually a problem? Does it really make any difference to the kind of tests we're doing? To answer that empirically, we're going to need to compare data sets which contain summary and linked variables and those which don't. Well, currently we don't possess those kind of comparison pairs. So in that situation, let me restrict myself here to just making the case that we need to prioritise this question and not just assume that linguistic data sets are problem-free. To make that point, let me focus on a paper by Riesink, Dunn and Singer, 2009, published in PLOS Biology. They were using the structure algorithm. This was a study of 160 linguistic variables across 121 languages. And what concerns us is the variables. The variables themselves are mostly carried over from two earlier studies by Dunn and colleagues published in the Peak Linguistics journal Language and in this journal that you'll all know, Science. So this is a set of variables that's been refined over several years and which has passed through the review process of both science and language. And despite those review processes, of the 160 variables in the Riesink paper, 54 are involved in some overt logical dependency with one another, which you can find just by reading the definition of the variable. This diagram shows a couple of subsets of those variables, and the lines here are showing dependencies. You see the dependencies in some cases are one-to-many, so if I just removed this variable here, I could clean it up quite nicely. Others, though, are many-to-many, and there's no easy way of getting yourself out of this without dumping a whole lot of data. Now, I'm a phonologist, so when I turn to phonology where I can examine things and evaluate them best, what I find of the 19 variables, there's 3 with overt logical dependencies, the type that you get when you just read the stuff, but there are 7 additional dependencies which I would call linked variables of the type that I mentioned before, and all of this is in a data set which in similar form has passed review of both science and language. So that is the state of play, and what are the implications of this? Well, I see the need for 3 principles for improved linguistic data sets. First of all, we linguists need to change from using macro variables that encode the psychological categories which have been of so much interest to linguists for 50 years, such as, is there a single category X, to micro variables that encode the empirical evidence from which speakers learn those categories. So what happens at the start of the word? What happens in the middle? What's the effect of adjacent sounds? These are questions which have not been sexy or publishable terribly much in linguistics before, but this is exactly what we need if we're going to do real statistics with data that's not nonsense. Secondly, of course, we should, as an integral part of the design process of these micro variables, explicitly identify and minimize the dependencies between variables. That's going to be very valuable. And third, where there is some irreducible residue of dependency, as I believe there will be, we should track the remaining dependencies, keep a catalogue of them, and that will allow us to extract multiple fully independent data sets subsets out of our larger data set and do interesting and valid stuff with the data. So these are 3 desiderata for a theory of linguistic data design, which now needs to be elaborated and whose time has most definitely come.